Number 36. Assuming a fixed amount of gas at constant pressure, complete the following table. So you're given V1, T1, and V2, T2 information, and you're asked to solve for either V2 or T2. And you got to do 3 of these problems. So when you have constant moles and constant pressure, that's a Charles law situation. And here's the mathematical form of Charles law. And we're going to use this equation for the 3 problems over here. So in the first one, we're solving for V2. And so take this equation and solve for V2. You bring the T2 over there. So V2 equals V1 T2 over T1. And taking all the information, plugging it in, the kelvins are going to cancel. So you don't have to do any unit conversions here. By the way, when you have temperatures in these gas laws, you make sure they're in kelvins. You have to have kelvins, and they already are. So Kelvin, Kelvin. Here we got a couple Celsius down there. We'll have to convert them, but the first one is good. So the kelvins are going to cancel, and you'll be left with milliliters. And doing the math, you get 21.428 milliliters, which rounds to 21 milliliters. In part B, we're solving for V2 this time. And we're told everything else, but we have T1 is in Celsius. So we got to convert T1. Okay, so take that 55 Celsius, you add 273, and that's going to be 328 Kelvin. Okay, and so you're going to plug that in for T1, and then plugging in V1 and T2, Kelvins now cancel, and doing the math, that you'll be left with milliliters and 116.6 milliliters, which rounds to 120 milliliters. Finally, part C, we're told V1, T1, and V2, and we're looking for T2. Here, the V1 and V2 units are the same, but the T1 is in Celsius again, so we got to convert that. So converting the T1 to Kelvin, take the negative 150, add 273, and that gives you 123 Kelvin. So plugging that in for T1, there you go. And then everything else, the liters cancel, you'll be left with Kelvin, and the math gives you 492 Kelvin, which rounds to 490 Kelvin.